Hi everyone, I want to make a quick video showing how to integrate x times the arctangent of x dx. This is similar to, or maybe identical to, the extra credit question on this week's homework, but when it got brought up in office hours today and I tried to solve it, I got stuck. So the least I can do is kind of show you how to solve it. So it starts out probably the way you would imagine, integration by parts, because we have a product of two things here that we're integrating. So we have to figure out what should be u and what should be dv. For reference, here's our integration by parts formula. So to figure out u, maybe you're deciding whether it should be equal to x or arctangent of x, and it's tempting to make it equal to x because then du will work out so nicely, the derivative of x would just give you a 1. But what's problematic there is if you make u the x, then the dv would be equal to arctangent of x. And so when you're trying to figure out v, what you're trying to figure out is what's the antiderivative of arctangent of x. And I don't think that that's something that you know. You're like, yeah, it's 1 over 1 plus x squared, right? No, that's the derivative of arctangent of x. We don't know the antiderivative of arctangent of x, so we wouldn't know what to put in this v spot, so we cannot make dv equal to arctangent of x, so we can't let u be equal to x. What I'm saying is that u should be equal to the arctangent of x, and then all that's left for dv is x dx. And if we have that u is arctangent of x, then du is easy enough to figure out. The derivative of arctangent of x, maybe you have memorized from Calc 1, is 1 over 1 plus x squared, or x squared plus 1, doesn't matter, dx. And v would just be the antiderivative of x, think x to the 1 power. So we add 1 to that exponent to make it x squared, and then we got a 1/2 down in front. So these are the four parts, easy enough to put them together using our integration by parts formula. U times v, I'll actually write v times u because I think it looks prettier, minus the integral of v du. I'm going to take this constant on the v and put that in front of the integral. So I'm left with, I don't know, I guess I can throw the x squared up on top over 1 plus x squared. And we got this far in office hours today, and then I was like, all right, and then I'm not sure what you do. One idea that we had was, all right, let's do integration by parts again, right? Let u be equal to, I don't know, maybe the x squared, and then dv is 1 over 1 plus x squared. Or maybe we have those backwards, and the u should have been 1 over 1 plus x squared, and the dv should have been, we tried a lot of different options. It didn't seem like we were getting anywhere. It seemed like we were just going around in circles. The reason it felt like we were going around in circles is because we were. It's because the solution here is not to do integration by parts again. And you're like, well, if you're not going to do integration by parts, what are you going to do? A u substitution ain't going to work, because if u is, I don't know, 1 plus x squared, for example, then du would be equal to 2x. But we got an x squared up here, not an x, so that ain't going to work. What are we going to do? Well, the answer is algebra. The answer is, it's a trick, and there's no way in hell you should have thought to do this, so it's kind of an unfair question for me to have asked you in the first place, hence this video. But what we're going to do is we're going to attempt to break this up into two different fractions. And you're like, wait a minute, I thought you told me that you can only break up one fraction into two fractions if the numerator is a sum of two things, not if the denominator is a sum. That's entirely true. A plus b over c is equal to a over c plus b over c. Think if you were adding fractions, how you turn this into this. But a over b plus c is certainly not equal to a over b plus a over c. Think like, I don't know, 1/2 plus 1/3 is certainly not 1/5, right? Because a half is more than a fifth and a third is more than a fifth. So if you're taking a half of a pizza and adding a third of a pizza, you're not getting a fifth of a pizza. Anyways, this is not true right here. So you're like, okay, so how's that help me? How am I going to break this up? Well, I'm going to get really clever. What we're going to end up doing is we're going to add a positive 1 and a negative 1 to the numerator. First off, if I add a positive 1 and a negative 1, I'm not changing the value of this thing, right? Because positive 1 minus 1 is just 0. So you can add 0 as much as you want without changing the value. But why? Well, that's a little bit harder, but let me first show you. If I add a positive 1 and a negative 1, I don't know, maybe I could write this like 1 plus x squared minus 1 over 1 plus x squared. Right, here's the positive 1 that I added, and here's the negative 1 that I added. So the value of this fraction is the same as the value of this fraction. And you're like, all right, I guess they're equal, but how does that help me? I can break up the numerator in kind of a clever way, treating this 1 plus x squared as the a in this identity, and the negative 1 as the b in this identity, and this 1 plus x squared in the denominator as the c in this identity. That gets me from this line to this line. If you have a hard time going from this line to this line, convince yourself it's true by going from this line back up to this line. Same denominator, all I got to do is add or subtract, in this case, the numerators. 1 plus x squared minus 1 would give me this line, and the 1 and the negative 1 would get me back up to this line. Whoa, I never would have thought to do that. Yeah, me neither, but don't worry about it. A lot of calculus 2 is not being able to see to do all this stuff. It's being able to follow somebody else doing it and then kind of remembering it the next time you run into an instance like this. What are we left with here? Well, 1 plus x squared over 1 plus x squared, that's easy. That's just equal to 1. And then 1 over 1 plus x squared, the antiderivative of that we know, that's just arctangent of x. So I think this is going to end up working out really well from here. The antiderivative of 1 is just our variable x, and then the antiderivative of 1 over 1 plus x squared is just arctangent of x. We tack on our constant. We can call this good. You could be completely done at this point if you want. I probably wouldn't leave it like this just because it looks kind of weird. I'd probably take the 1/2 and factor them out in front. And note, really, there's 3 terms here, but this 1/2 is hitting both of these terms because of the parentheses. So this 1/2 and this 1/2 can go out in front of the entire thing. And then from this term, I'm left with x squared arctangent of x. And then from my third term here, the negative and the negative will cancel out. And so I'll be left with arctangent of x. And then for the second of my terms, I'll just have this negative from this negative x. I think this is a little bit prettier than this, but I guess beauty's kind of in the eye of the beholder. You could call this good if you wanted to. You could rewrite it here. You could rewrite it in lots of different ways, in different orders. The point was just to find the antiderivative, which I think we now have.